Hello everyone, and thank you so much for joining me today. We're going to find ways to measure angles in today's lesson. Our focus today will be on acute angles, which are angles that are less than 90 degrees, right angles, that are equal to 90 degrees, and obtuse angles, which are angles that are more than 90 degrees and less than 180 degrees. Okay? Now, to help us do this, there are some materials that are definitely beneficial for us as far as helping us measure angles. Okay, so we can call them tools, I suppose. Okay. One tool that you'd want to definitely have is a compass. Okay. Another tool that's very helpful is just your standard ruler. For straight edges. Okay. A geometry template is a good tool for measuring angles. Okay, if you don't have a geometry template, then I would definitely suggest investing in one. I bought this one for like, I don't know, $8 off of Amazon. Okay, and of course a protractor. And this is my protractor here. I like this protractor. I actually got it off of Amazon as well. This is actually technically a semi-protractor. A protractor would be a full circle. Semi means that it's just half or part of the circle. It's a really cool protractor because this can help me measure up to 10 centimeters, and it also is used as a really good pointer, so I can make really good demonstrations here with the degrees of angles. Okay. Now, you may ask yourself, okay, why does Mr. M have a compass in a video when we are measuring angles? We don't need a compass. Well, not necessarily, but I love to demonstrate measuring angles by first drawing a circle. Okay? And this is a compass, obviously. Okay, when you hold a compass, never hold the arms of the compass once you set it. Okay? So, the way you set your compass is you want the pencil to be just a little bit farther than the anchor point. Okay, so this is called an anchor point. All right, I can demonstrate that. Have a small pencil. There's different type of compasses. Okay. That's too short. That's not long enough. That's pretty good right there. Just longer than your anchor point, okay? All right, now the first thing I'm going to do, and I do this with all my students to demonstrate angles, okay, is make sure you do not ever touch the arms of your compass when you've set your compass. Okay, so I'm going to put it right down there for my anchor point. Okay, I'm going to draw a circle. Okay, there's different techniques. Some kids, when you're small, I would suggest standing instead of sitting. All right, another thing you can do once you've set your anchor point here. Okay, and notice I've kind of lost my anchor point, but I can find it, no problem. Is to stand and then move your paper like this if you're a small child and it's difficult for you to actually draw the circle. Just move your paper with it, it's fine. Okay, and just practice this. Okay, get that dexterity down, that muscle memory. All right, so now that we've done that, the next thing we're going to do, find our anchor point. Okay, and we're going to draw something that looks like a bullseye. When I have kids use the rulers, right, the way I teach children is they will not draw a straight line unless you demonstrate this. See the edge right here of my paper? Make sure that the edge of the ruler is lined up with the edge of my paper. So I do stuff like this. Just a little trick that I've learned over the years working with kids. So there we go. It's lined up well. Go like this. Okay. Now, I'm going to do the same thing this way. Okay, so now I have what looks like a bullseye clearly. All right. I'm going to go ahead and start to erase the curved edges. All right, we have a center point here that is where my anchor point was. All right. So now the next thing I want to do is I want to measure our right angle here by using your protractor. Okay, this little point right here, and you can see it, is where the anchor point is. It's like a little hole, and each good protractors always have a little hole right there. Okay, that's where your anchor point's going to be. All right. Now, make sure that this line right here that you've drawn is lined up with where the line is on your protractor. That's very, very important for measuring angles. Okay. All right, so what I have here is I have my anchor point and the hole right here on my protractor. And then I have this line on the straight line right there. Okay. It's a little off still. Different protractors look different ways, but you will see that this line right here is important for different reasons. So now I can move this here. Okay. And what you see is this line. Still gonna mess with that a little. There we go. Okay, you'll see this line that's right here is measured right at the 90 degrees. Okay. So that's a good way to demonstrate what a 90-degree angle is because this line that I made is pointing to that 90-degree angle. Okay, so that's how we want to use this protractor. If you have a protractor that doesn't do that, okay, what you want to do is just take another straight edge or just kind of eyeball the line going up to see that it's matched with 90 degrees. I can even do that if I wanted to. Okay. So there's different ways that you can see that that's a 90-degree angle. Now there's a special symbol that we use for a 90-degree angle. So all I'm doing is I'm looking at the angle right here. Angles will form where two lines meet. Okay? Yeah, that's fine. Angles will form where two or more sides meet at a vertex or at a point. At a point called a vertex. In this case, the vertex is right here where our anchor point is. All right, so if this is 90 degrees, this is probably 90 degrees too. Now, instead of using my protractor, what I'll demonstrate is to use a corner of a paper, okay? This is also a good way to show a 90-degree angle because I know that a 90-degree angle is a corner. So if I put my paper right there, I can clearly see that my lines go this way and this way. So that's 90 degrees too. Now, we call a straight line a 180-degree angle because when we add these two right angles up, we get 180 degrees. Okay, so see what happens. So I'm going to add these two angles up and I'm going to ignore the bottom. Okay, so I'm ignoring all the lines on the bottom. So 90 plus 90 equals 180. And we use this little symbol right here, which means degrees. Try not to think of temperature. When you're measuring angles, okay, we're not thinking about temperature, even though we actually use the same symbol. All right? So half a circle equals 180 degrees. If you're into extreme sports or something like that, if you snowboard or if you skateboard, you know that a 180 is half of a, it's when you flip halfway instead of actually, all the way around, okay? Now let's see what happens when we continue to add our angles. Okay, so we know that this is 90 degrees too, because it's a corner. And we also know that this is 90 degrees as well, because this is a corner. All right, so what did I just do? Okay, I made a circle first, and then I looked at the vertex here in the middle where all these lines meet, and I measured these little angles here. And each one of them is a corner, which is 90 degrees. So now, if you take a look, I have 4 90-degree angles. So I'm going to do this. 90 times 4. I know 4 times 9 is 36, and 36 tenths equals 360. So 4 right angles equals 360 degrees. All right, now if a half of a circle is 180 degrees, what is a full circle? You guessed it, 360 degrees. So 360 degrees is a full circle. Okay? And this is the best way for you to understand how to measure angles, is to first draw a circle, then find all of the angles that are next to the vertex right here, and then you're going to start measuring. All right, and we're going to talk about why that is so important. All right, when I measure a 90-degree angle, and I'm just going to do it right here. Might get a little bit lazy, but that's okay. You can measure the 90-degree angle in so many different ways. Okay, and it can look like it's going this way. All right. It could look like it's going this way. Use your imagination. All right, 90-degree angle is just a corner. You can even do them this way if you wanted to. This is called a non-standard way of measuring an angle, just using the side of my paper. Okay. Let's see how else we can do this. So I just did it that way. I did it that way, maybe like this. Oops. It's hard to use your imagination for these, isn't it? Definitely. I wanted to go this way instead. There we go. All right, so whichever way you're going to, it can look in so many different ways, but remember that it's just a corner. All right. So now remember, we're going to go back to this idea here. Let's take a look at what an acute angle is. We know that acute angles are less than 90 degrees. All right, we understand what right angles are. Right angles are equal to 90 degrees. Okay, and we've just taken a look at some examples of right angles. Now let's take an example of acute angles. All right. So let me get my paper here. Okay, I love to do stuff like this because it's just so much fun for me. All right, so I'm going to take my ruler because I know that that's a really good tool for me to use. And instead of making a line that goes up and down and then across to make a corner, I'm going to actually tilt it a little bit. Okay. And we know some angles do look like this. Okay. Now, if an angle is not a right angle, we don't put the little the little boxy looking symbol in there. We go like this instead. Okay? So in other words, this symbol here is just for right angles. Okay, only. You never use this symbol here if the angle is not a right angle. Okay, so now I know that this is going to be less than 90 degrees. Because it looks like the corner, it looks like if it were a corner and then it just kind of went in just a little bit. So it's called acute. On acute angle. Oops. It's very easy to remember because cute things are small. Okay, so now what I want to do is I want to estimate this angle. I know it's less than 90 degrees, but it doesn't look like it's much less than 90 degrees. A little bit, but not too much. So I want to make an estimation and say that this angle perhaps is about 80 degrees instead. Okay, so what I'm going to do to test this theory is I'm going to get my protractor. Okay, I'm going to put that right there. Okay, that little hole right there by the vertex where those two lines met. Okay, now I'm going to do this. Okay, but I have to make sure that this line is matched up with my line here on my protractor. It has to. If it's like this, you're not measuring correctly. Okay, so make sure that it matches up with this line right here. Okay, and that's going to be our 180 degree line. There we go, that's better. Okay, so I was off with my estimation by quite a bit. Actually. All right, so if I take a look here, it's about 70 degrees, not 110. So if you take a look here, this says 110 and this says 70. We'll talk about why this one says 110 and this one says 70 here in a little bit. Okay, but for now, just know that if it's less than 90 degrees, then it cannot be 110. So think about that. So if I'm taking a look at this angle right here, all right, it looks like it's about 69 degrees to me. You can estimate it to 70, that's fine, it really doesn't matter. So this angle here equals 69 degrees. Okay. Now, remember what I did here with this example, okay, that we can actually look at angles from up, down, sideways, flipped over, all kinds of different ways, okay? Some angles that we measure are not going to go in this direction. So let's take a look at an acute angle that does not go in that direction. Okay, so first thing I want to do is draw a line. Okay, this is about a 90-degree angle, so I want to make sure that it's smaller to make it acute. All right, so I'm going to go like this. And notice I'm just kind of making this up, and you can do that too. All right. Obviously, this is going in an opposite direction. Clearly, this is less than 90 degrees because it's less than a corner. It's not 90 degrees, once again, because I am going to use this little mark right here. So it has to be an acute angle. And I think you kids understand that. All right, so what I'm going to do is I'm going to put this here. Okay, I'm still getting used to my new protractor. I'm going to make sure that, okay, that it's lined up with the vertex and that this line matches up with mine. Now I'm going to go this way. The best way to think about these numbers, kids, is that, okay, I don't want to look at, remember this other way? Remember how I measured this one? Okay, if you took a look at it, I was looking at the blue. And this is hard for children to understand, especially when they're starting. Okay, I was looking at this blue right here. This blue mark that said about 69 degrees. Okay? But here, because the angle is going in a different direction, I'm not going to look at the blue. I'm going to look at the clear. All right? And the best way, like I just said, for you to do this is to understand that this is less than 90, so it can't be 120. So just use logic when it comes to that, okay? So my vertex is set here. Okay. I have my flat line lined up to my line. I'm looking like this. All right, so now I know it's less than 90, so it can't be more than 90, so it's definitely not 120. So I look here, 60, 61, 62, 63. So this angle here is equal to 63 degrees. So basically, kids, what this is, why you have these numbers on top and you have these numbers on bottom is because of the way you're measuring the angle, the way the angle is positioned. Okay, so obviously this angle is positioned going this way. This angle is positioned going that way. That's why we measure it differently on the protractor. And that's very confusing when you're first learning how to do a protractor. Now, most protractors don't have this little lever here to help you. In fact, this is the only one I've ever seen like that. I like it though. What I would suggest you do, just kind of eyeball it. Follow the line up. The most important thing, once again, is to set this point right here on your vertex and to have this line across of the protractor across the line that you've drawn or the line that's already there. Okay, so if I look and I just follow it up, I can see it's 63 degrees. If it's difficult for you to do that, use a straight edge to help you. Okay, and you can see it right there. All right, so both of these are what's called acute angles because they're less than 90 degrees. This is an acute angle, and this is an acute angle. Anything that's less than 90 degrees is called acute. All right, so remember that. Okay, now we're going to look at angles that are more than 90 degrees, but less than 180 degrees, and those are called obtuse angles. Okay. So I'm going to take my protractor once again. My ruler, sorry. I'm going to draw a straight line like this. Now I know that a right angle should look like this, right? But instead of going in and making the angle smaller, I'm going to go out. So I'm going to go like this. Okay, so I know that this angle now is going to be more than 90 degrees, but it doesn't go all the way past your half circle line. Okay, and that's important to remember. So this is going to be more than 90 degrees, but less than 180 degrees. So it's an obtuse angle. All right, and that's the type of angle that one is. It's called obtuse. Okay, and I have that here. So we've looked at acute angles. We've looked at right angles. Now we're going to take a look at obtuse angles. Awesome. Okay, so I know that this is going to be more than 90 degrees. What I want to do once again is set my protractor, go to the vertex, make sure that that line is straight. Okay, if it were 90 degrees, it'd be here, but it's more than 90 degrees. Okay, so I'm going to go like this. It can't be 70. Remember, use your logic. Okay, it can't be 70. It looks like 110, about 111 degrees right there. Okay. So this angle is equal to 111 degrees. It looks so weird. All right, so now I'm going to do it in the opposite direction. Go like that. And just mess around with this. All you need is a protractor, a pencil, okay? And you can understand measuring degrees of angles, but it's not easy, especially for like third graders at first. You know, you may need to ask some help at home. That's fine. Okay, I want to measure this angle right here. Okay, so now let's go ahead and take a look at this. I want to estimate. Okay, my estimation was bad last time. I thought that I know it's more than 90 degrees, because 90 degrees would be like right here. Okay, but how much more is it than 90 degrees? So estimating is important. I think it's probably about 120 degrees, this angle here. Let's see if I'm right. Okay, match up my vertex there. Make sure that my protractor is on the line. Okay. There's where 120 degrees would be if you see it. Okay. So my estimation was better this time. I was off by probably about 3 degrees. 120, 121, 122, about 122 degrees. See? Okay, matches up pretty good. So that's a better estimation. I did better that time than last time. All right, anyhow. So that's about 122 degrees, this angle. All right, so these are called obtuse angles. More than 90, less than 180. And that's really all you kids really need to know, 3rd through 5th, is that acute angles are less than 90. Right angles are equal to 90. Obtuse angles are more than 90 degrees and less than 180 degrees. Those are what you really need to focus on. Okay. Now, people like to do this to help them understand angles. Okay? What people like to do is to give each of these little points names. Okay, so let's imagine that this angle right here, I'm going to actually put a point. Okay? I don't want to go into so much technical stuff, but let's just imagine that there are other points right here. I can actually name this angle A, B, and C. Okay? So, I'm going to say that this angle is angle ABC. So, I can do something like this, all right? Okay? And that's what they say, like ABC is equal to 90 degrees. This right here is just a symbol. I don't know if they've changed the symbol, but when I was teaching it looks like this. So what this means right here is angle. I know it doesn't have the cute little boxy thing, but this is just a symbol. All right, just like a plus symbol means add, or a minus symbol means subtract. Right? You get the idea. This symbol here means angle. All right, and it always will. Okay, so now by doing this, it helps us understand that B is the center point where these lines meet. And it tells us that angle ABC is equal to 90 degrees. All right, so let's take a look at some other ones. All right, let's take a look at our acute angles. Okay, and we're going to just try to, actually try to give these, this angle a name. Okay, so I'm going to put a point out here. That's fine. And I'm going to name this angle Jim. J-I-M. So I'm going to write it in a mathematical way. I'm going to say that angle Jim is equal to 69 degrees. See what I mean? This middle letter will always show where those two lines meet, and I hope you remember that. Okay, it shows the vertex. You might ask, well, what's going on with these other points here? It's too technical right now for third, fourth, and fifth. But there can be, technically, there could be lines coming out of these sides, through these sides, okay? And you will understand that later on, but for now, we're just trying to measure just an angle, okay? So now, I'm just gonna go like that. I want to give this one a name. And I'm going to say that this is angle Job, J-O-B. Okay, and I know that angle J-O-B is equal to 63 degrees. I also know that it's an acute angle. Once again, just like before, recognize that that middle letter is the vertex of this angle where the two lines meet. Okay? Let's take a look at our obtuse angles that we just drew. Okay. And you're going to do the same similar thing. You're going to name them different things. So, how about Deb? D-E-B. Angle Deb is equal to 111 degrees. Now, if I didn't have this at all, and you just showed me this, I would know that it's an obtuse angle without even looking at it. Because of course I know that obtuse angles are more than 90 but less than 180. I could draw angle Deb. That would be fine. All I would need was just pencil and paper and a protractor. And if I were to practice, I might not even need that. I haven't practiced angles in a while. Okay, but you saw that my estimation for angles got better as I practiced. Okay, so I can also name this angle BED. You can do that too. Okay, so you can call it, if you don't want to call it angle Deb, you can call it angle Bed. That's okay to do. It's the same angle. All right, however you want to think of that. But notice that letter here is where the vertex is, where those two lines meet. Okay? So let's go ahead and take a look at angle 122. Okay, so I'll just name it tan. All right. So angle tan is equal to 122 degrees. It's obtuse. Remember, you can also name it angle net if you want to. Same angle, same degrees. You get it? Okay, cool. All right, so that's a wonderful little introduction to understanding measuring angles. All right, so what I've done is I've printed out this worksheet for us. 3 types of angles. And we're going to do a little bit of practicing. Okay, I got this off of Super Teacher Worksheets. It's about $20, $25 or something a year, but it's totally worth it. Okay, so the only thing it wants us to do is to figure out, and if you take a look here, these are called rays, okay, because these little points right here, okay, the ray, if the arrow keeps going, what it really means is that this line right here, this ray, can just continue to go infinitely into different directions. I mean, into that direction where the arrow is shown. Okay, sometimes there's just points where it just ends. That's why there's little arrows right here, and that's fine. It doesn't really matter. So it says label each angle as acute, obtuse, or right. All right, so let's take a look at that. Remember that acute is less than 90 degrees. Remember that obtuse is more than 90 degrees but less than 180 degrees. And remember that a right angle is 90 degrees. Notice the symbols too, okay? So this symbol right here looks like this. It looks like a square here on the corner. I know that that's a right angle. So this is a right angle here. Because I know it's a right angle, I can write it as such. I can say that right angle, okay, Don't worry about that. Remember, it's just a symbol for an angle. DEF is equal to 90 degrees. Or I can say that angle fed is equal to 90 degrees. However you want to say it. FED is equal to 90 degrees. DEF is equal to 90 degrees. That's that angle right there. Okay. Now what I want to do, I just want to continue to look. I can see this right here. Okay, angle EFG or angle GFE is equal to 90 degrees as well, because I can clearly see that angle right here is right, so this is right. Okay, if I want to extend my understanding, then I do this, just like I did before. EFG, angle EFG is equal to 90 degrees. Angle GFE is equal to 90 degrees. Okay, now what I want to do is I want to find those, now that I've found the two right angles on my worksheet, I want to find the ones that are less than 90 degrees. So I'm on a hunt for those acute angles. Clearly I can see that angle ABC is less than 90 degrees, so it's acute. Okay, less than 90 degrees. Okay, and you kids already are so intelligent that you understand exactly what I'm going to do next. I'm going to label it. Angle ABC is equal to, I don't know what it is yet, but I'm going to find out soon enough. So I want to use my estimation strategies. Okay, if a 90-degree angle was like this, like a corner, this actually looks like it's almost half of a 90-degree angle. So I want to think about what half of a 90-degree angle is. Well, I know that half of 90 equals 45. So let me see if my estimation is correct. An estimation is really important for understanding angles. Okay, so I'm going to move this out of the way. Okay, come over here. All right, make sure that my vertex is right there on the corner where B is labeled. Okay, make sure that my protractor, the line, the 180-degree line, is on the ray where you see that line right there. Okay, and then I'm going to move this here. Okay. All right, now I'm pretty close. Let me see if I got that correct. There we go. That's where that is. Okay, I want to move, and you just have to mess with it. All right, there we go. Come in like this. All right, and then we're going to see where that angle is. Goes this way. I know it's not, remember, I know it's not 130, obviously, because it's less than 90. Okay, and it looks like it's just about 40 here. Okay. 42 degrees. 42 or 43. It is important to be as accurate as possible, but we don't have to be obsessed over it, not yet. Later on, when you get into upper grades, you want to be more precise, but in elementary school, if you say 42, if you say 43 degrees, it's okay. So I have it at 42 degrees. Okay. So angle ABC is 42 degrees. And of course, angle CBA is the same. Okay. Not a bad estimation. Remember, my estimation was 45 degrees for that angle. So my estimation strategies are getting better. All right, let's look at another example here. Okay, let's take a look at angle GHI. I can see that, and I like to do this sometimes to help me. This would be where the right angle would be, just eyeballing it sort of. So I see that it goes past 90 degrees, so it's obtuse. Because I know that obtuse is going to be greater than 90 degrees, but less than 180 degrees. Okay. Awesome. All right, so let's go ahead and take a look at angle GHI, or of course you can call it angle IHG. Estimating this is difficult without practice. Okay, I'm going to say it's about 135 degrees. All right, I'm not quite sure. I haven't been teaching 5th grade in a while, 5th and 4th grade. We don't really do a lot of this in 3rd grade, but not yet, unfortunately. School's closed, so we didn't get a chance to do it. We mostly focus on 90-degree angles. But my estimation, it's about 135 degrees, but we'll see. So I'm going to put this right here where the vertex is, if I can find it. There we go. Okay. I'm going to try to get my line up there and lined up with this other line here. And that's a pretty good estimate. Yep. Okay. You can get better at estimating these lines the more you practice. Okay, and I can tell that that line is at the 135 degree mark. Remember, I know it's not 45 because it is obtuse, which is going to be greater than 90 and less than 180. All right, so I was able to do that pretty good. Not bad, Mr. M. My estimation strategies are working better for degrees of angles. Okay, so now I'm not going to finish the whole entire page, okay, but there's different things you can do. You know, don't hesitate, like number 6 right here. Measuring angles is all about, oh, look, I found another right angle. I didn't even realize. Didn't see that symbol. Okay, measuring angles is all about turning your page different ways. Get messy, okay? You know, stick your tongue out and concentrate. That's what I do. All right, you really want to get in there. If you're a kid, stand up out of your seat. Okay, view it from top down. All right, so this is going to be a 90-degree angle clearly, because that's a right angle. Bam, there it is, see? Okay, right where that arrow is going, right on top of that arrow. All right, so you guys get the idea. You guys are smart. Okay, so angle. And it's okay if you do that. Some people do that. I think that looks kind of cool too. Angle PQR is equal to 90 degrees, it's right. Or, of course, angle RQP is equal to 90 degrees. Alrighty, so that is, so let's finish up without measuring all these ones. Okay, what does this look like to you? Okay, you're correct if you said it's acute. What does this angle look like to you? Okay, you were correct if you said it's acute. How about this angle here? You were correct if you said obtuse. How about this angle here? You were correct if you said acute. How about this angle here? 9. You were correct if you said obtuse. And look, it almost looks like a straight line. So you can estimate it. You can say, well, it's just less than 180 degrees. All right. That's how you use estimation strategies. So that's obtuse. What does this angle look like to you? More than 90, less than 180. That's obtuse. What does this angle look like to you? This looks less than 90, so it's acute. Okay? So once again, all right, there's a lot of skills that are based in that, okay? And it gets much more complicated. Okay, that's kind of basic. But remember where we started this whole entire lesson. Okay, we started this entire lesson from simply drawing a circle. Okay, and that's how I always teach the kids. Draw your circle. Start measuring these angles inside. This is a great introduction to what a 90-degree angle is. It's a great introduction to understand that half a circle is 180 degrees. When you add these two angles up right here, interior angles, okay? It's a great introduction to understand why they call a circle 360 degrees, because these 4 interior angles equal to the sum of 360 degrees. That's why they call it that. All right? And remember this, angles will form where 2 or more sides meet at a point called a vertex. Awesome. Okay, so we're almost finished. Okay, don't forget this. This is very important. Ways to measure angles. Once again, an acute angle is less than 90 degrees. I always think of the word cute, and it's small. A right angle is always equal to 90 degrees, and it has that special symbol. Obtuse angles are more than 90 degrees and less than 180 degrees. Some tools to help us with today's lessons were a compass, a ruler, a geometry template, and, of course, a semi-protractor. But it's okay to call a semi-protractor just a protractor. Alrighty. So once again, practice and have fun. And before you know it, you'll understand measuring angles in no time. Have a good one until we see you again.